Welcome to the Explainer. Today, we're going to unpack exactly how a modern enterprise database is actually built. We're looking at this through the eyes of a professional database administrator or architect, so you get the real inside scoop. By the time we're done here, you'll understand the complete, kind of fascinating flow of data, literally from a user's initial click all the way down to a physical spinning disk. Okay, here is our blueprint for today. We're going to cover 1. Architecture fundamentals. 2. The 3-level blueprint. 3. Client-server models. 4. Inside Oracle architecture. 5. The banking transaction. And finally, 6. The DBA perspective. Let's dive right in.
Section 1. Architecture fundamentals. The engine of the enterprise.
So at its core, database architecture isn't just about, throwing a bunch of data onto a hard drive. Not at all. It's the foundational software blueprint that dictates exactly how your data is stored, processed, and retrieved. Whether you're dealing with traditional relational structures or those newer, highly flexible NoSQL models designed for massive big data, the architecture is literally the framework holding the whole shebang together. And this right here is exactly why organizations invest so heavily in getting this right. I mean, we're living in an era where managing a terabyte or more of data on a single server is just everyday business. The right architecture directly drives system performance, it ensures enterprise-grade security, it dictates how smoothly your apps can scale up with user demand, and ultimately, it decides whether your application stays online during a crisis. It's really the difference between a minor hiccup and catastrophic downtime.
Moving on to Section 2, the 3-level blueprint, ANSI Spark. Now, what's really fascinating here is how we separate the user's experience from the physical hardware using this specific 3-layered model. It acts as a massive organizational translator. Up at the top, we've got the external level. This is the fast, customized view for the end user. It completely hides irrelevant data and only shows them what they're actually authorized to see. Below that is the conceptual level. This is where the database administrator defines the global logic, the data items, and how they all relate to each other. And finally, at the very bottom, we have the internal level, which rigorously defines exactly how that data is physically stored on the actual hardware. So, why do we do this? Well, the crucial point of this separation is a concept called logical data independence. But what does that mean in plain English? Basically, it means a DBA can go in, swap out hard drives, move files around, or completely reorganize the physical internal schema, and the end user up at the external level, they won't notice a single glitch. Their view remains perfectly intact. It's pretty brilliant.
Section 3. Client-server models connecting to the data.
Understanding this is absolutely crucial because network traffic is so often the main culprit behind poor database performance. Just notice the evolution of network design here. On the left, we've got a direct 2-tier connection, right? The user interface on the client desktop talks directly to the database server. But on the right, we see the highly scalable 3-tier or multi-tier model. Here, an application server sits right in the middle, completely separating the client's presentation logic from the database's data management services. Now, while the 2-tier setup is super straightforward to build for small, simple projects, enterprise environments overwhelmingly rely on the 3-tier model. And why is this the industry standard? Well, as user numbers explode, 2-tier systems can suffer massive performance hits. The 3-tier model, which often uses a thin client web browser, is vastly more scalable. Plus, and this is huge, it is substantially more secure because the client is never, ever allowed to communicate directly with the database. All right, Section 4. Inside Oracle architecture, the engine room. Let's zoom straight into an industry standard so we can see how these theories look in the real world. Honestly, the biggest hurdle for beginners and junior DBAs is separating these two concepts, the Oracle instance versus the Oracle database. Think of it kind of like this. The Oracle instance is like the Microsoft Word application itself. It exists entirely in your computer's active memory, or RAM. The Oracle database, on the other hand, is like the actual Word document you saved. It represents the physical files permanently saved on your hard disk. Notice the relationship we're looking at here. The memory structures and background processes of the instance sit up top, actively managing and maintaining the physical database files sitting below them. A good rule of thumb to remember: an instance can exist without a database, and a database can exist without an instance. Let's take a peek inside that instance, because reading from memory is incredibly fast. I mean, way faster than reading from a physical disk. Oracle relies heavily on memory structures. It uses the Shared System Global Area, or SGA, for caching data and SQL statements that multiple users might need to access. Conversely, it allocates private program global areas, or PGAs, as exclusive, isolated work areas for individual user processes. Now, operating diligently behind the scenes within the instance are the background processes. These guys are the true unsung heroes of database architecture. You've got the process monitor and system monitor handling critical cleanup and recovery tasks, but the real heavy lifters for data movement are the database writer, which constantly flushes changed data from high-speed memory down to the disk, and the log writer, which is basically constantly saving your transaction history. And that brings us to the very bottom of our architecture, the physical files. Your data files hold the actual tables and information. Your control files store the structural metadata you need just to open the database. And your read log files? Those are your ultimate insurance policy. They record every single change made, ensuring that if the power goes out, no committed data is ever lost. Absolutely crucial. Section 5. The real-world enterprise example. A bonking transaction. To see how this all builds together into a cohesive system, let's trace a real-world enterprise example. Watch this data flow as we follow a single banking transaction. So a user clicks transfer funds on their thin client browser at the external tier. That request hits the middle application server, which processes the business logic. It then hands off a SQL query to the database server. Next, an Oracle server process parses that SQL using the PGA and modifies the account balance cached in the shared SGA memory. Finally, the database writer commits that changed balance permanently to the physical data files, while the log writer simultaneously secures the transaction record in the redo logs. It's literally a flawless, synchronized dance across multiple architectural layers. Section 6. The DBA Career Perspective. So why does understanding all this intricate digital plumbing actually matter for your career as a database administrator or architect? Well, as database expert Craig S. Mullins points out, handling performance problems is truly an enterprise-wide endeavor. Performance isn't just about tweaking a line of SQL code. It requires a holistic understanding. You have to know how the operating system, the network traffic, the memory allocation, and the disk I/O all interact with each other. You have to understand the supply and demand of data within the system to really manage it effectively. Knowing this architecture intimately is exactly what separates average technicians from master architects. It empowers you to pinpoint exactly whether a bottleneck is a network latency issue or a memory cache problem. It allows you to design completely unbreakable backup and recovery strategies simply because you know exactly how redo logs interact with data files. And as systems evolve, this architectural baseline is what's going to allow you to successfully design high-availability clusters and securely migrate enterprise systems straight into modern cloud environments. Which brings us to our final thought for this explainer. If an enterprise database fails right now, do you know exactly where in the architecture to look? Well, armed with the blueprint of how data flows from a user's screen, through the application tier, into the active memory instance, and permanently down to the spinning disk, you now have the foundational tools to answer that exact question. Keep exploring the architecture that runs our world, and thanks so much for joining me today.